Here is example number 2. I am going to draw the picture of this quadratic. I'm going to do it by standard form and factoring and quadratic formula so you can see the connection between the three. Standard form is A for your x squared term, that's the coefficient of that term, B the coefficient of your linear term x, and C the number term that has no letter. So here I have 1x squared, that's my A, I have 4x, that's my B, and there is no number. So my C in this case is going to be 0, and I'm going to show you the difference between the factoring and quadratic formula because we're missing a term here. Still doable, so here we go. The vertex, axis of symmetry, which is the center line, is the vertical line opposite b over 2a. That's how you're going to find where the center is of your picture. Opposite of my 4 is negative 4. So opposite of positive 4, negative 4. And divide by double my a, 2 times 1 means that I have really negative 4 divided by 2, which means negative 2 is my center line for this picture. So at negative 2, my graph is going to center around this, so it will be the same on the right side as it is the left side of that center line, that vertical line, x equals, and I should have put negative 2. So let me scribble that out real quick. Okay, negative 2. Now, if I know my center is at negative 2, that means my vertex has to land on that line somewhere. And what I'm going to do next, why I'm going to do this is because if my center is negative 2, I can just plug that number into my function to find where it lands. So let me clear out my calculator. Where you see all of your x's, you're going to substitute in parentheses the number negative 2. So in parentheses for my 1x squared, I'm going to plug in negative 2 plus 4 times my x value of negative 2. No plus anything. I don't need to hit plus 0. And I'm going to see that vertex land at negative 4. So I'll plot that point 1, 2, 3, 4 down from my x-axis. Okay, now, pattern of my points, or I can make a table. I can make a table here. So if I know my vertex is negative 2, 4, I'm going to put that right in the center just so I can see visually some repetition here. To the right of negative 2 will be negative 1 and 0 and 1. To the left of negative 2 would be negative 3 and negative 4 and negative 5. I can plug those numbers in just like I plugged this into my calculator, the negative 2, or you can follow your pattern of change, your pattern of the points of a quadratic. I'm going to quickly show you here as I'm plugging in negative 3 and negative 1. You should get the same number here. So here we go, negative 3. When I plug in negative 3, I get out the number negative 3. That should be identical as when I plug in the number on the right side of the center, negative 1. And I also get negative 3. So negative 3, 1, 2, 3. Negative 1, 1, 2, 3 down. Okay, now I'm going to plug in the number negative 4. That gets me 0. That should mirror the same as when I plug in the number 0. So negative 4, 0, 0, 0, and one more. I need to insert my negative and change that 0 to a 5. I need to insert the negative and change that to negative 5. This will be 5, so negative 5 up 1, 2, 3, 4, 5. And that should be exactly the same as what I get when I plug in the number positive 1. So I'll delete that negative and change that to be a 1. So 1, 2, 3, 4, 5. Notice your pattern of points from your vertex. We went out 1, out 2, out 3. So from here is out 1, out 2, out 3. Notice your pattern going up. Up 1, up 4, up 9. So up 1 here, up 1, 2, 3, 4. From the vertex out 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, that pattern of your quadratics, if your A is 1 from the vertex, will go out 1, 2, 3, 4, and up your squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Now, if it's a negative x squared, that just means this would have gone upside down. If you have a different number than 1x squared, you take your a and you multiply each of these numbers. If your a is not 1, a will alter your pattern by, instead of going up 1, 4, 9, 16, maybe it'll go 2x squared. So if it goes double that, it would be double 1, 2. It would be double 4, 8, double 9, 18, and double 16, 32. So your a will alter that pattern, but since my a is 1, my pattern's not altered. Now factoring. My favorite way to graph is by factoring, if it's factorable, that is, because it's quick and efficient. So if you see that you have two terms and you notice they have something in common, you would factor by what is called the GCF. I noticed that both of these terms have a common factor, a greatest common factor of x. And if I divide out the greatest common factor of x, I will have an x left and a plus 4. Now there's my function factored. Now, if I'm solving for my x-intercepts, okay, then that means I'm going to set my function equal to y, because every x-intercept is labeled x comma 0 on the graph. That's why it crosses that x-axis, is because the y value is 0. So now I'm going to set my function equal to 0, and I am going to solve my factors to get my x-intercepts, so my solutions. If I have x times this quantity equals 0, then that means either this quantity or x is equal to 0, and how I solve is by setting all my factors equal to 0. So that means x equals 0, x plus 4 could equal 0, and now when I solve, there's one of my roots. And notice, that's right here, 0, 0 is a point on our grid. There it is. Here's where you get the other x-intercept by solving for x. I'm going to subtract 4 on both sides, so my x is alone, and my other x-intercept is negative 4. Notice in my table, I had that number negative 4. So those factors, set them equal to 0, are your x-intercepts. Unlike from standard form, you don't find your intercepts first, your solutions, you find your vertex first. With that opposite b over 2a, get that value and plug it in for the y value of your vertex. Now, quadratic formula, again, you got to know the quadratic formula to fill it out. Quadratic formula and factoring will both help you find your x-intercepts. Okay, so here we go. My x-intercept will land at. Now, if you don't have the formula memorized, I went through it over here. You could write that down. Opposite b plus minus square root of b squared minus 4ac all over 2a. Opposite of b. Opposite of positive 4 is negative 4. Plus and minus the square root of my b squared. 4 times 4 is 16. Minus the number 4 times my a value, which is 1. Times my c value, I have none, so that is 0 for none. Divide by double a. 2 times my a value of 1. Now I'm going to simplify, and I will show you I will get the exact same answers as my factoring did from what is called quadratic formula. Okay, simplifying, here we go. Negative 4 plus and minus the square root of 16 minus 4 times 1 is 4. 4 times 0 is 0. What's 16 minus 0? 16. 2 times 1 for my denominator means I will divide by 2. Okay, now what I'm going to do is simplify my square root of 16. What number times itself gets you 16? It's 4. And now here's where you're going to see your two solutions. I'm going to get one solution from when I do the addition and one from when I do the subtraction part of the formula, this plus and minus. So the addition part, negative 4 plus 4, do that first before you divide by 2. If you're using your calculator, you have to do negative 4 plus 4 and hit enter and then divide by 2, which means you need 0 and then divide by 2, which is why I had 0 for my x-intercept. So that's the origin, okay? Then negative 4 minus 4 divided by 2. Again, you have to do the numerator before you do the denominator. Negative 4 minus 4 is negative 8, and then divide by 2. That's why it says all over 2a would get you negative 4. And again, we showed negative 4 from our factoring, from our table, and now from our quadratic formula. And again, there's your picture. Out 1, up 1, out 2, up 4, out 3, up 9, out 4, up 16 if we could, but that will be off your picture.